Folks, welcome to session 2 of the third Google GTech meetup in Singapore. So now we have two presentations in this session. First presentation is by Buuuk.com by Jon Petersen. Let me invite Jon Petersen to talk about his wonderful product. He's going to show us some live demo as well. Right? Jon Petersen.
Okay, good afternoon everyone. My name is Jon Petersen and I'm a co-founder of a company called Buuuk, which is a Singapore-based company which creates applications for the mobile platform, primarily the iPhone and Android. And in this session I'm going to be taking you through some of the issues with creating location-based services on the mobile platform. I'm going to start off by just giving you a bit of an introduction to the Buuuk application in case some of you don't know of it. I'm sure some of you will not have seen it, so I'll give you a quick overview of what Buuuk is. But I really want to focus in this session on some of the technology behind Buuuk, around how we use these mobile devices to get someone's location and then use that location to deliver up contextually relevant information. In our case, that contextually relevant information is restaurants and bars, but these issues and the technologies I'm going to be discussing apply to any location problem. Okay, how many people here have got iPhones or Android devices? Just raise your hand. Okay, a few of you. Okay, those of you who've got Android or iPhone devices, there's this great application you can download called Buuuk. It's a free application and it allows you to locate bars and restaurants. And once you've found those bars and restaurants, you can obviously go and eat there, and you can review them and vote on them and provide us with various sort of user-generated content which then enhances the app for other users. So this is kind of what it looks like when you start it up on the iPhone. And essentially, it's there to help you find locations that are close to you. Now, that's not always what our users want to do, but if you're out and about with a mobile phone, walking around Singapore, that's typically what you want to do. Most of our users want to start the application and immediately find the stuff that's closest to them. That's the stuff that's most contextually relevant to them in terms of their location. So if you open the app and you just press the Nearby button, which is what most users do when they start it, you will see a list of restaurant locations. So this is actually me starting the app from my home. So my closest restaurant location is a coffee shop called Changjin, which is actually, it's a very famous coffee shop. It's on East Coast Road. It's one of the few traditional Singaporean coffee shops that's left in Singapore. I do recommend you visit it. So Changjin is 191 meters from my home. And the next closest is Tamon Japanese restaurant, also on East Coast Road. East Coast Road, as most of you will know, is a bit of a foodie's paradise. So I've got all these cool restaurants very close to me. A lot of these restaurants, as you see, have had ratings, so we get this star rating here. So Changjin has got 4-star rating, Peranakan has got 3 stars, and so on. Once you've got that list of restaurants, the next kind of logical thing to do is to maybe pull up a map of them. So we have the lat longs of all of those restaurants, obviously. We also have, in order to pull up this map, we have to have the lat long of the user. So in this case, what we're looking at is a map of a bunch of restaurants in Singapore, and the blue dot is the user's location. So on the iPhone and on the Android phone, if you open up the mapping application or you open up maps within an application, which is what we're doing here, the application finds you and puts a blue dot where you are. It also will sometimes put a blue circle around that dot, which I'll talk more about later, because that dot may or may not be accurate. And that's one of the things I'm going to talk about in this presentation. Each of the black pins here is a restaurant. The blue pin is the user's location. Something else that we do within the application is we also allow users to view the restaurants around them using augmented reality. A lot of you will probably have heard of augmented reality. For those of you who haven't, basically augmented reality is taking virtual information and overlaying it on the real world. So this is a screenshot from my iPhone looking out from my house. Okay, so if I go to the front of my house and look out, and I open Buuuk, and I go to a list of restaurants, and then I turn the phone to landscape, this is the view that pops up. And what it's doing is it's using the camera of the iPhone to show me a picture of what's in front of me. So in this case, you can see my neighbours' houses. But then it overlays on that information about the restaurants that are in the direction that I'm looking. So I'm looking here up towards, kind of up towards East Coast Road, right? So you can see Chin Mi Chin appears once again in my virtual reality view, 191 metres away. But then there are other restaurants that are varying distances away, but the crucial thing here is that they are all in that direction. So we've kind of moved from our traditional map view. If you think of that map that I showed you earlier, we would just be drawing a circle around the user and showing them all the things around them within a certain distance. Here we're showing them things that are in the direction they're looking within a certain distance. Okay? And using this augmented reality, we can give this fairly neat way of allowing people to navigate in a fairly intuitive way. No maps required, right? You have to be a little bit careful you don't kind of walk into lampposts. But basically, you can take your device, pan around, see what's in a particular direction you're going, and head in that direction. And as you head in that direction, we will update the distances. So this provides just another way for people to navigate to geographical reference points, in our case, restaurants and bars. And you can see we do a little radar view here. So this thing here is our radar view. And each little white dot there represents a restaurant. So all we're loading in this augmented reality view is restaurants within a certain bearing, or between two bearings. Okay? We don't bother loading all of the restaurants that are behind you until you turn around. And then as you turn around, we start loading all of the restaurants that fall within your new bearing. Okay? So what I'm going to do through the rest of this session is try and explain how some of this works technically. It won't get too technical, because I'm not too technical. First off, let's look at how we just locate a user in the first place. Okay, this technology is only of any use, whether it's augmented reality or whether it's a traditional map, if we can locate the user or locate their device. Okay, in the first place. So in the case of Buuuk, we've got around now 80,000 users. About between 4,000 and 6,000 of those users every day use the app. And there are 73,000 restaurant locations which we can serve up to them across 56 cities in Asia and Australia and the Middle East. So the first thing we do when someone opens the app, of course, is to figure out where they are. Otherwise, we can't do the rest of the work. So this is kind of the crucial thing that happens when you start Buuuk, is we try and figure out where you are, or where your device is. And we assume you're pretty close to your device, right? So these are the locations where people could open up Buuuk. In fact, as we'll see in a moment, anyone can open Buuuk anywhere in the world. But if they open Buuuk at any of these locations, they will get something interesting. If they open Buuuk in other locations, they will get restaurants that are possibly a long swim away. Right? But if you're in any of these locations, you should get some quite interesting data. So the device, when someone opens Buuuk, the device provides us with the location, and Buuuk is a client-server application. So the device sends the user's latitude and longitude back to our servers. Okay? Our server then reverse geocodes that lat long, and this is where Google's services come in. Okay? Clearly Google provide the maps within the application, but Google also provide a service to do this reverse geocoding. Reverse geocoding is the process of taking lat-long coordinates and turning them into an address. Yeah? An address is a human-readable form of a geographical location. And once we've got that address, we know what content to start serving up to somebody. The way in which we do this, in fact, the whole back end, the server side of Buuuk is written in Ruby. And there's a very neat Ruby gem or a Ruby library called Geo-kit, which actually does all of this hard work for us. So Geo-kit goes off to Google servers, sends Google servers the lat long, gets the JSON response back from Google, and then passes that JSON response for us. And Google are pretty nice about this. Google allows us to do this for free, basically, provided we don't go over certain limits. And Google will in fact send back 3 locations for any reverse geocode. So we actually have a chance to actually choose which might be the most accurate one. In our case, we literally just take the first one. Because in fact, what we're most interested in is not someone's precise address at this point. We already know their lat long, so we have the precise location. What we need to know is what city or country they're in. Because if we know their city or country, then we can serve up restaurants in that city or country. We don't want users in Abu Dhabi looking at restaurants in Sydney, unless they specifically choose to load Sydney as their location. We want them just to see restaurants which are relevant to them given their location. Abu Dhabi has a kind of defined perimeter to it, its border. So anybody within that border should be served up restaurants within that border. Okay, borders are a strange concept, and I'll talk more about that in a moment. So essentially what we do is we take that, we reverse geocode it, and we assign a city code. That city code then determines what content from now on we will serve up to the user, okay, which will be a subset of our restaurant data. Now one of the things that we do, if you look over on the right-hand side here, we've got Google Earth open. Because our server is collecting this information, one of the nice things we can do is we can collect information on every location used to start up our application. So every single day we produce a report where it's basically a Google Earth, it's a KMZ file, which can be displayed in Google Earth, which shows us where every single user uses our application. So I'm going to use this to show you some of the issues around locating users. So let's look at the first thing, which is basically when I open this, it opens at a lat long of 00. Okay, 00 is actually somewhere in the Atlantic Ocean off Africa. And you'll see that there's a pin there. And a black pin represents a Buuuk user, someone who's opened our application, for whom we could not serve up local restaurants. A black pin doesn't mean we couldn't get their location. A black pin means they were in a location not served by us at the moment. We don't have any restaurants in the Atlantic Ocean, right? But these are particularly interesting ones because they've also been assigned a lat long of 00. And these are Buuuk users over like the past 2 days that we're looking at here. So all of these users went and opened the application, and for some reason we got 00 as their location. If I tap on one of these, we'll get some information and it's all blank, right? So we had this 00 location come back to us from the phone. We sent it to Google. Google quite rightly sent us nothing back. Because 00 is not a valid location. Well, it is a valid location, but it's not on a landmass. And Google won't geocode the sea. They don't return Atlantic Ocean. They just return nothing. So we've got 2 problems here. The main problem here is not Google's fault. The main problem is actually Google Android's fault. Okay, these are all Android devices. If you look at the bottom here, we code all of these pins according to whether they're from an iPhone or the Android. And unfortunately, on a lot of Android devices, getting the location can be very slow because we require GPS, particularly on older versions of our application. On the original versions of our application, we did not include Wi-Fi geolocation, which is a system from a company called Skyhook. Some of you may have heard of Skyhook. Skyhook provide a Wi-Fi location service, which is very good. Wi-Fi location can be very fast. So as soon as the device is turned on, we can get that Wi-Fi location. On the early versions of our app on Android, we didn't include Skyhook because there were some licensing issues. On the iPhone, it's built in. So on the iPhone, we almost always get very good location as soon as the device is turned on. But on Android, for people using old versions of our application, there can be a delay. And we can't just wait, right? We have to give the user the chance to use the app. So at some point we just say, look, we can't find you. we're going to put you at 0, 0. Okay? So these users, so in the last 2 days there's like 20 users, all of them on Android devices, who have been put in the middle of the sea, basically. Let's look at some other interesting locations that throw up some examples of some other problems around location. So even when you can get the correct lat long from the device, there are still some issues around locating people accurately. Let's have a look at somewhere in Singapore. So I'm going to pan over to Singapore, and you'll start seeing orange pins appearing. An orange pin is a book user opening the app in a city that we support. Okay? So all of these, if I scroll out a bit, so in Singapore, all of these orange pins are people opening book, right? And we're getting that long and we've plotted them. And down at the bottom here, locating people in Singapore is actually pretty good because Google's geocoder for Singapore is quite good. But it has a particular black spot we've discovered. This is the Sentosa Gateway, right? So, funnily enough, if you're in Singapore and you're in the middle of the harbour, Google correctly geocodes you, reverse geocodes you. So that lat long in the middle of the harbour returns Singapore. But a lat long on the gateway returns nothing. Why? I don't know. Well, the reason is, let's go back to my slides here. The reason is that human beings are involved in geography, unfortunately. And human beings kind of create geography or a definition of geography. Addresses are a human construct. There are lots of qualitative decisions that need to go into the process of deciding someone's location. As soon as you move away from lat long, yeah? Lat long is kind of a nice mathematical thing we can work with, but as soon as you turn lat long into an address, human beings are involved in determining what that address is, right? So in this particular case, it just happens to be a hole for some reason in Google's geocoder which doesn't find people on the Sentosa Gateway. Elsewhere in Singapore, we don't have a problem. All of the others seem to get found. Like I say, even ones in the harbour. So even right out here, I don't know, where is this? Some industrial complex? Yeah, Google knows that's part of Singapore, right? And if I pan out, go over here, it knows that this island over here is in Singapore. But interestingly enough, it thinks it's Jurong. Okay, and that ain't Jurong. So you need to bear in mind that if you're doing this work, you are dealing with other human beings who are building this back-end system at Google. And they've made some decisions that may or may not be correct, but also there are certain things about interpreting this information and how it's interpreted. Let's take a look at another interesting location problem. These are users in Canberra. Okay, so we're viewing here Canberra, Australia. And you can see they've pretty much all been correctly located, so same city as Canberra for all of these users, except for this one here, where for some reason Google doesn't return the city, but they do return the postcode. And interestingly enough, we've discovered that in Australia, if you're in a body of water, i.e. you're in a lake or a river, and by the way, this doesn't mean the user is actually there. Okay, this just means that their location was approximated to that spot, right? So you could be at Vivo City in Singapore, but the location may show you in the harbour because there's some inaccuracy around the location information, right? But if we take a lat long in Australia that's in a body of water, like in a harbour or a river, Google doesn't know it's in Australia, but funnily enough, it knows the postcode. I can't explain that. I'm not sure anybody will be able to explain that because it's very strange, right? They know it's actually they do know it's in Australia. You can see the country code is returned. The country code is returned as AU, but there is no state information. So I don't know they're in Canberra. I just know they're in Australia, right? But the postcode tells me they're in Canberra. So for Australian addresses, what we do is, if city is not returned by Google, we take the postcode and use the postcode to locate them. So there's always ways around these things, but you only find ways around these things if you find the problem. kind of why we run this report. We run this Google Earth file so we can look at where these black pins are and see if there are any black pins in places there shouldn't be, like in the middle of Canberra. The other interesting thing about Canberra is it's a geographic region completely surrounded by another geographic region which we cover. Okay? So you take Singapore. Singapore's dead easy to work with because it's a single landmass surrounded by a body of water. In Singapore, if you are up at the north, if you're up at Woodlands in Singapore, we will not show you restaurants in JB, even though they may be your closest restaurants. Because we figure that body of water is an obstacle that you probably don't want to go through on your way for lunch. So Singapore is nicely contained, but in Canberra it's a different problem. Canberra is a land mass defined by some human geography which has a border around it completely within New South Wales. And New South Wales is another location which we cover. So if you're in Canberra, there may be a restaurant 200 metres away which is in New South Wales and is very easy to get to. It doesn't involve crossing a body of water, it doesn't involve getting out your passport. So in Canberra and Sydney we have a concept of a mega city. And Canberra is actually a subset of New South Wales. So users within Canberra for certain information will just see Canberra. For other information they will see all of New South Wales. Okay? Let's have a look at one more location before we leave Google Earth, because it's always very interesting to see what people are using your application right around the world. So we're going to go off to California. And we'll see they're all black pins, right? Because we don't cover any restaurants in America or Europe at the moment. We're purely Asia, Middle East and Australasia. But in the last few days, quite a few users have used the app. I don't know why. Maybe there are other developers, maybe it's a free download, right? Why wouldn't they download it and play with it? Maybe they're going on holiday and they want to do some research before they go on holiday. But this area is always particularly interesting because there are some quite interesting companies here, right? So we've got a user in Cupertino. In fact, we've got two users in Cupertino, but this one is particularly interesting. Anybody recognise that? It's Apple, right? The address is 1 Infinite Loop, Cupertino, and it's Apple's headquarters. So kind of dream of dreams, this is Steve Jobs, right? Planning his own job. So somebody in Apple, and we actually regularly see this when we submit a new app for approval, right? Because the app has to be tested in Cupertino. But we haven't submitted a new version for 2 months. So I don't know why somebody in Apple was using it 2 days ago, but anyway, it's nice. Maybe they're going to put us in one of their adverts. Yeah, dream on, right? It'll be Urban Spoon again. Okay, and then we've got another one up here, Mountain View. Let's have a look at where this user is. Anybody recognise that? Andrew?
Google.
It's Google's headquarters. In fact, they've been located at some car park just outside. But I'm assuming that's somebody in one of those office buildings, and that's Googleplex, right? So somebody at Google has been using the app, which again is kind of nice. Maybe they want to buy us. Yeah, I got lots of dreams, right? Interestingly enough, it's somebody at Google using an iPhone. So iPhone, Android, same app available, they're using an iPhone. Probably not a bad decision at the moment. Things are changing fast. Android's getting to be a very, very good system. Okay, so that's just a bit of fun. This is a way in which we can test whether our location of users is working as we want it to work in Google Earth. Let's carry on. I want to talk a little bit about some more of the technical issues. Okay, so when someone starts the app, we get their location, right? We have their lat long, and we have this database of 76,000 restaurants, all with a lat long. Calculating distances between 2 lat longs is pretty trivial. And in fact, it's made even easier because lots of smart people have written libraries to allow you to do it. So if you're a Ruby user, for example, you may be using Active Record as your database layer. If you're using Active Record as your database layer, there's actually a Ruby gem. It's GeoKit again, the same thing we use for reverse geocoding. GeoKit creates what are called distance-based finders. And distance-based finders, to keep this not very technical, basically give us as developers a shortcut to calculating distance. Because calculating distance is a little bit tricky. It involves minor rocket science, right? Because of the shape of the Earth. Yeah, with lat long, we're not just looking at people on a flat grid and calculating distance between them. We're looking at people on a curved surface. And so we have to use something called the Haversine formula. Fortunately, these guys who built GeoKit have built the Haversine formula into it. So we can use something which is really pretty elegant. It's as simple as this to select somebody's restaurants within 10 kilometers. Okay, now if you're not a developer, this will look complicated, but if you're a developer, this is kind of as simple as it gets, right? All we do is we specify a table to look at, we specify that we want to find all of the restaurants in that table, where the origin is a pair of lat long coordinates. We're within 10, and GeoKit allows us to either specify metric or imperial as our measurement units. We use metric. And they're going to be sorted by distance. So we can take this finder and produce this code very simply. Now let's look at something slightly more complicated, because in that case we're just selecting from all of the circumference around you, right? They're just going to be within a certain distance, within 10 kilometers in any direction from you. And that's no good for augmented reality. Because with augmented reality, the whole point is we show you stuff in a certain direction. So to do augmented reality, we get a third parameter back from the device. As well as the lat and the long, the device sends us the user's bearing. Okay, you're just using traditional compass degrees, right? So if I'm looking due north, my bearing is 0. If I'm looking due east, my bearing is 90, and so on, round the points of the compass. So the 3GS phone and the Android phone both have a compass in them, which can return us that bearing. So if I point my phone in a certain direction, the phone will send back to our servers that bearing. So we can then take that bearing to try and calculate stuff within a span from that bearing. Because clearly the bearing is going to be one single point. And if we look along one line looking for restaurants, we'll probably find none, right? We need to take a span. So we play around with this, depending on what city we're in and how many restaurants we've got, what the density is, we change that span. So in some cities we might do 90 degrees either side of your bearing, yeah, which will show you everything that way, right? If we take, in Singapore, we do 35 degrees, because there's so many restaurants in Singapore. So we take your bearing, we add on 35 degrees and we minus 35 degrees, and we calculate all of the restaurants within a certain distance within that bearing up to a limit of 10. And again, we can tweak all this from the server side depending on how we think it's working. So we can change those bearings, we can change the number of restaurants being returned, we can change the distance. We set the distance to 10,000 kilometers. So if I go down to East Coast Park and use augmented reality on my iPhone to look for restaurants, I get restaurants in Jakarta. Okay? Because using my bearing, they are my 10 closest restaurants. The rest is sea. Okay? But if I turn around, I'm going to be back to Chin Chin on East Coast Road. Okay? So we take 10,000 kilometers as the limit. The reason we have to build a limit on is because the Earth is round. And at some point, if we just keep going, we end up back up our own backside. And I don't know what that causes, but it's probably not nice. So we've put this limit on to avoid going around the world. The other interesting thing is, the bearings themselves end up with a distance that is infinite if you keep them going. Right, close to me, the kind of span of the bearing is short. As I get to Jakarta, the span of the bearing is large. So in fact, all the restaurants appear in one list if they're in the same place. Yeah, because they're looking at a distance now on the horizon, which is massive. Okay, so there are some interesting issues about how to build a UI to display this type of information. One of the problems with this is, unfortunately, GeoKit doesn't support calculations with bearings. Okay, they support the traditional distance calculation. They do not support selecting within bearing. So now I have the user's location I have two bearings which tend to infinity, right, unless I put a limit on them. And I have a bunch of restaurants within that. How do I calculate which of the restaurants within that? Well, unfortunately, like I say, there's no library for that yet. So we have to do that bit ourselves. But it's still relatively simple. It just requires some basic trigonometry to basically build an SQL statement that will select from within certain bearings. The bearings themselves need a bit of manipulation because bearing is like a clock face, right, going from 0 around to 360. And this is not minus 45, it's whatever that is. It's 315, right, on the clock face. It's 315 degrees, not minus 45. So this is 315, this is 45. So if we take someone's 0, we can't minus 45 from it. If someone's looking north, we can't minus 45, we actually have to turn it to 315. So we have to do a modulus calculation, which is why this low bearing and high bearing calculations are there. We use modulus to get around that problem of the clock face problem. And then the key bit is the bit in red, which is the bit that uses haversine formulae, which takes account of the curvature of the Earth, to calculate within these bearings what restaurants in our database fall within those bearings. And then eventually it just becomes a SQL statement. Okay? And really that's pretty much all I wanted to share with you. I've probably gone well over my time, have I? But I will take questions if there are any.
So let's open the floor for questions. So there are 2 microphones. If you have any questions for John, please raise your hands. Wow, the demo is so good they don't have any questions. Okay.
Actually, I saw a video demo on YouTube. It's actually the application of Buuuk. It can recognize the landmark.
Yeah, it's East Coast Road, right?
Yeah.
Yeah, I was out there filming, right? And if you hear the sound, it's the buses going past trying to run me over.
Yes. Actually, it looks quite fantastic. I just wondering how Buuuk recognize landmarks.
How does it recognize landmarks?
Yeah.
Well, it knows where you are, and we know the lat long of the landmark, so we can figure out where it is in relation to you, because we have your bearing as well as your location.
So you don't have any visual recognition, right? Do you have?
There's no visual recognition involved. No, it's purely mathematical.
Okay.
It's just we know your lat long, we know the object's lat long, and we know the bearing, we know your view. So we know where to place it on the screen as the camera pans around, based on that chaining of bearing. Yeah. There are systems out there that are using optical recognition. So there are some photo systems now where if you take a photo of like a major landmark, it will geolocate the photo. So if you take a picture of the Eiffel Tower, it knows you're by the Eiffel Tower because it can recognize the Eiffel Tower. So there are some image recognition systems out there, but they'll never be able to cover every restaurant in the world, right?
I know how many landmarks you have in the database?
76,000.
I mean the landmarks, just the restaurants and landmarks altogether.
It's all restaurants, right? They're all restaurant bars or cafes, and there are 76,000 of them.
Why not in North America?
We just haven't got there yet. And to be honest, there are lots of competitors in America, and nobody in Asia really doing this type of thing. So Yelp have a very strong presence already. And Asia's kind of a bit of an open playing field at the moment, so we figure it's an interesting place to play. We do Beijing, yeah. Beijing and Hong Kong. We haven't added Shanghai, but we'll be adding it soon.
I don't know if you've seen I don't know if you know who Pranav Mystery is. Pranav Mystery is this guy from MIT who has recently launched, he's still researching on this product called the Sixth Sense product. So what that product essentially does is, if I say take a picture, you know, he has this device, he doesn't even need a phone. So if I just put my say hands like this, you know, in a picture mode, it's going to take a picture, and it could also give me information, more information. If I even do this, look at you, I can get more information on you. So Buuuk essentially could also sort of amalgamate with that sort of technology, I feel. That was just one of the things that.
This is the guy who demonstrated at the TED talk. I've seen the demo, and it's fantastic stuff.
Exactly.
It's a bit sci-fi for us at the moment, but I'm sure one day we'll all be doing that, right?
Exactly. No, But Buuuk also essentially, if you see, it's using a device like the iPhone. The bearing, the view it takes, and it gives me like additional information on that. So essentially, it could be used with the 6 sense.
This is kind of a very primitive version of what he's doing. He's taken it to a whole new level, right? But this is kind of, at least this is real, right? This is commercializable now. What he does, he's kind of showing where this could end up. And it's very interesting stuff. He has it hanging around his neck, right?
Yep.
Yeah. If any of you want to see this stuff, just go and do a search on YouTube for TED, the TED Talks, and it's called Sixth Sense, right?
Yeah.
And you'll see this guy doing some really crazy augmented reality
It's
stuff.
like Minority Report.
It's very interesting.
Okay, so my question now is coming back.
Oh, that's a question now.
So the question is different from the comment. But anyways, the question is that is it just used for restaurants? Just restaurants?
At the moment, it could be used for anything, right? We happen to have built a restaurant app, but we've also built location apps for other things. There are certain things that I would not use this for currently, right? One of the problems with location is it's currently inaccurate, right? So you could have a user, and if, let's say you can't get, they're not inside, there's no GPS signal, they're in a building, and there's no Wi-Fi, then we have to use cell tower. That's what the iPhone and Android devices both use. Okay, eventually they have to drop to cell tower to get your location. That could be up to 500 meters out. So we built an application recently, for example, for locating AED devices. AED devices are automatic emergency defibrillators, right? They restart your heart. And there's 300 of these devices around Singapore. And we built, for a charity, we built an application that allows people to find these devices. And they said, oh, we want augmented reality in it. And we said, no. Right? Because if we do augmented reality with something that is that crucial and get it wrong, we're in trouble. And it's very easy to get it wrong. So let's say I'm in this building and the device has somehow located me because of the cell tower issue 200 meters out there. And I'm using augmented reality to find a device which is closer than 200 meters to me. The device could be 20 meters that way, and we could tell the user it's 20 meters that way because their location is not accurate, right? The location of the AED device is accurate. We know where that is, and that lat long doesn't change. But we don't know that we can accurately locate the user. So we could potentially send somebody 20 meters in completely the wrong direction to find a defibrillator device. Yeah, we don't want to do that. That would be very bad. So we said to them, don't use augmented reality, just use traditional maps, and we use pictures. So we use a description and pictures to try and lead somebody to the device. Because augmented reality, because of the location issue, can be very inaccurate with close-by objects. If the objects are far away, the fact we've got the user location slightly inaccurate doesn't matter. Yeah, if you're looking at restaurants a kilometre away, and your location is out by 100 meters, those restaurants are still basically in the right location. And if you look through, you'll see them. But if it's a very close-by object, we could be pointing you in completely the wrong direction. So there are some limits to kind of mission-critical stuff where you wouldn't want to use augmented reality at the moment. Okay.
You know, Lyre, there's a famous Lyre, it's from Amsterdam, it's like a 3D browser, you can say. They do something.
Lyre?
Yeah. You've heard of that?
Yes, I have. Yeah. It's on Android, right, I think?
Yeah.
Yeah,
basically, they do next step, I think. They focus on restaurants, but they kind of focus on. They try to have a layer on top of it.
Yeah, I mean, once you've cracked displaying stuff, you can display anything you want, right? It's just it becomes a user interface issue.
Yeah. That's
because how many points can a user? You've got a small screen. How many points can a user work through? So you have to start building layers which users can tick on and so on. So.
Okay. Next question from Andrew.
Two quick questions. One, how did you manage to source restaurants in 56 cities so quickly? And the second question is, why did you stop at 3 U's? Why didn't you go for 4 U's in your name?
Thanks for that. I'll take the second one first. We wanted a .com name, right? And we wanted something that wasn't related to food, but sounded like kind of what we do. So as in book a table, right? Book a restaurant, book a hotel. You can book anything. Book.com, as in BOO.com, unfortunately has gone. Book, BOOO.com has gone. Book with 5 O's has gone. So we went to U's, right? And we started adding U's. And with 3 U's, we got the domain name.
And in India, book, you know, if you Hindi,
it means hunger, right?
Yeah.
Yeah, someone's told us since then, this is complete coincidence, that book in Pashtun, I think, means hunger. Right. Anyway, the first question, how did we source the data? Well, Google was a good friend. Right? A lot of this stuff is publicly available on sources like Google and other directories. A lot of the data most recently has actually come from a credit card company who we work with. If you open Buuuk, you'll figure out which credit card company it is. It's Amex. Okay, Amex have provided us, in return for some publicity in Buuuk, actually they paid us as well, which is quite nice, but they gave us their whole merchant database. Unfortunately, it didn't have lat longs on it. Okay, but again, Google is our friend, right? Particularly in places like Australia, geocoding addresses is trivial. They're down to house number. Singapore's pretty easy. Other locations, like in Malaysia, we have to get it done by hand, virtually. In Jakarta, we hired a guy on a moped to go around with a GPS-enabled phone. And we use guys through systems like Elance to basically go to Google Earth and Wikimapia and figure out locations. So all we need basically to start with is we need the name, the address, and the telephone number. And then if we can geocode it and have a guess at the cuisine, because we need to put it into one of our categories, then it goes into Buuuk. But that whole side of things has kind of been commoditized by you guys, right?
Hard work,
It's cool, it's nice, it's great, because you've built a platform. Now we can get on with the interesting stuff.
Okay, folks, last question. Sorry, can you take it offline?
One question is how much time it takes before the server can send back the information to the mobile devices?
The information on the reverse geocoding?
Yeah.
It's about 3 seconds.
3 seconds?
It depends on the user's connection, right? If they're on, because on one of these devices you could be on a fast Wi-Fi connection, you could be on a 3G connection, you could be on a GPRS 2G connection. So depending on the connection is how long it will take. If you were to just take information from a device, send it to our servers, we send it to Google, Google sends it back to our servers, we send it back to the device, then the only issue is some latency involved in that. Typically it's around 3 seconds or less. On a 2G device it may take slightly longer. Clearly one of the nice things about using Google is they have all this bandwidth, right? So when you're talking to a Google server, things happen fast.
And besides the searching for restaurant using the mobile devices, you consider other application scenarios for building a commercial product using your geolocation technique?
Yeah, we built some applications for banks. Banks, like locating ATMs and branches. We built this thing for finding defibrillators. Basically, we can do anything where we can get the points of interest.
How do you make money?
How do we make money? Good question. At the moment, we make some money out of Buuuk because we have banks who sponsor offers. So we work with Amex and Maybank, and they pay us. Some individual restaurants pay us to be featured. And we spend about half our time doing applications for other people. So people see Buuuk and they say, I want something like that. I'm a bank. Let my customers find my ATMs. That's the typical thing. Banks, they got quite a lot of money. Okay, they did a couple of years ago, they had none, right? Now all of a sudden they're flush. How does that work?
Can you give some more detail about how you get restaurant data from Google?
Sorry?
Can you give some more detail about how you get restaurant phone number, address from Google?
Yeah, Google have a search API you can use, which has some limits on it. And you need to keep within their terms of use, right, Andrew? But you can search Google and they'll send you back JSON formatted addresses.
Okay.
You might actually want to use Bing now, because Bing have far more relaxed terms of use. I guess Google might catch up one day, right? Yeah, Google have, I can't remember what the restrictions are, Andrew, do you know? Or anybody from Google here know the restrictions on the terms of use? For the search, it's a certain number you can do a day and a certain number you can... Eventually, basically, they shut down your server, right? Because you have an API key, and they turn it off and they stop sending you results. but Bing actually doesn't limit it. So if you want to collect address data at the moment, particularly in the US and Europe, Bing is a great source. I love this battle going on, Bing versus Google. It's only good for us developers, right?
Okay, thank you folks. If you have any more questions, I suggest that you take it offline with Jon Petersen. Let's just join our hands to thank the speaker. Okay, the last speaker for the day, but we have two short demos after this. Is Changjin from ShowNearby. Before I hand over the floor to Changjin, I just want to highlight this presentation in that all of us know that Street View APIs were launched in Singapore by Andrew only on Wednesday morning, right, at 10 o'clock. This startup, right, can I call you a startup, right, came into the picture only on Wednesday evening, and within 2 days, they have used the API to make and integrate into their product. That makes this presentation much more useful, and also it shows that how easy it is to use Street View APIs and in general Google APIs, in that if some of you have not tried Google APIs, you may want to try. You don't have to have the hesitation that it's going to take a lot of time to read and things like that. So here is a company which has already used the Street View APIs and integrated into their live product. Changjin from ShowNearby, please. Thanks.
Hi. Firstly, I would like to thank Talk to invite me here to give a short presentation on how we utilize Google Map API. Okay. So I'll give a brief introduction of what my company do. Okay, my company is ShowNearby. So the name of the company already tell you that we are showing you what's nearby. So we are actually a LBS, location-based services company, providing location-based services. Okay, give me a minute. Try to open the browser. Sorry, I'm not a Mac user. Okay, let me continue. Today my presentation is Seeing is Believing. So I'm going to show you some of the screenshot of how we come about using Google Maps. Okay, so ask yourself this question. How do you search for a place, a shop, or a retail shop online when there's no map solutions or maps visual to aid you in those days? So probably you will go to a directory listing like Yellow Pages, Green Books, all this. And you will see something like that, a list, show you, let's say this is one of my pages in my site. So you search for shopping, so we will come up with a list of shopping centers in a way. So Google Map came. So this is how we use the Google Map. Okay, so from there we can add on layers to Google Maps, like creating the bars, putting bus informations, the bus numbers, and coming along we are going to put the arrival times. So with a map, right, it enhances your visual. So now, not only listing, you can see it with a map visual. So we tried on different interface along our ways. So this is our version 2. Okay, basically, this one, it will auto detect your location. If you are aware, there's 2 browsers currently that's location awareness supported, which is the Firefox and Chrome. Okay, so if you're willing to share your location, the browser is able to detect where you are on its best guess. Okay, so other than maps, there's also directions. So this is one we have come up with. Basically, you can use their APIs, right, to integrate directions. Okay, then after they come up with more things. So now you can drag and have an alternative route. Okay, then you learn their APIs, you can come up with more stuff. Now you can add on multiple points. So this can be a prototype for your journey planner. So you want to go to